Hello everyone. In this video, we are going to learn about Arbitrum Orbit. So, before we understand about Arbitrum Orbit, we need to understand the three-layer architecture. So, the layer 1 is Ethereum, which is a foundational layer providing security and settlement for all the transactions. Then comes layer 2, like Arbitrum, which is a scalable execution layer which uses roll-up technology for cost efficiency. And then comes Orbit, which is layer 3, which provides customizable environments to enable tailored blockchain solutions for developers. Why should we choose Orbit? First one is economics. Here you can set custom fee structures and token models for your own blockchain. Second one is performance. Here you can have dedicated throughput for your application. For example, Ethereum, which is layer 1, and Arbitrum, which is layer 2, they each have specific dedicated throughput, like number of transactions processed per second. But if your application requires that number to be high, then you can build your own custom chain using Orbit Stack to have more throughput than L1 or L2. Third one is compliance. So you can geofence your chain and you can control it from the regulatory perspective. So if you are building an application where you require a custom chain which should be geofenced to specific users of a certain region or an organization, then you can do so. Fourth one is governance. So here you have control over your chain and you can decide how to govern your chain. Now there are two data availability modes. First one is rollup and second one is AnyTrust. Rollup mode provides maximum security guarantees by storing the transaction data on layer 1. This method ensures that all data is accessible and verifiable but at a higher cost. Whereas AnyTrust mode offers a more cost-effective solution using an off-chain data availability committee. But it reduces cost, it introduces trust assumptions that may not be suitable for all applications. So, how can you choose the right mode for your application? The choice between rollup and antitrust depends on your application requirements. For example, a high value applications like DeFi should prioritize security, so they should go with rollup mode. Whereas cost sensitive applications such as gaming can benefit from antitrust's lower expenses. These are the core roles in Orbit chains. First one is deployer, who initiates the deployment of core contracts. Owner, who controls governance and upgrades of chain. Poster, who submits the transactions in batch-wise manner to parent chain. And validator, who confirms these transactions and resolves any disputes. Here are the configuration essentials. So first you need to have unique network identifier for your chain, which is chain ID. Then you need to set data availability committee to true if you want to go with any trust mode or false for rollup. And you need to have these addresses for the core rules. Now let's go through the deployment steps. So Arbitrum Orbit has an official Orbit SDK. So you can use this SDK to deploy your custom chain. First, you need to import this prepare chain config function from the Orbit SDK. You need to configure your Orbit chain ID, chain owner, and data availability committee. For now, we will set it to false for rollup. If you want to go with any trust, then you can set it to true. And then uh, we need to configure it using prepare chain config, where you can pass chain ID and initial chain owner as well as data availability committee. The second step is initialization of deployment process. So here you need to configure deployer private key, batch poster private key, and validators private keys in your environment variables. Then you need to create public client consisting of chain and transport layer as HTTP. Then you can use this function create rollup prepared deployment params config, which can be imported from Arbitrum Orbit SDK. And then you need to pass this public client, chain ID, owner, and chain config, which we prepared in the last step. Then you need to execute create rollup function. So you need to import this function, and to create an orbit chain, you need to pass these parameters, create rollup config, batch poster, validators, max data size, which is the maximum size of data which is going to be posted for your application. Uh, this is in bytes, and once you have configured it, you can execute the transaction to have your orbit chain. Once you have deployed your orbit chain, here are the post-deployment operations that you need to perform to access and maintain the orbit chain. So first you need to configure your wallet by adding new network details, including the name, chain ID, RPC URL, and currency to ensure interaction with your orbit chain. Then you need to expose RPC endpoint for users and applications to allow external interactions and facilitate communication with your chain. Then you need to configure infrastructure, set up necessary infrastructure by deploying batch booster services and validator nodes to ensure smooth operations and effective transaction processing on your chain. Then you can progressively move towards decentralization by having multi-sig admins, and you can have community RFCs to have any upgrades on your chain. You can have council and time lock token meter voting with quorum and proposal thresholds. Now we have understood what is Arbitrum Orbit chain and how we can prepare it and deploy it. But now let's try to actually deploy it. So you can go to our modules by XCan platform. Here you will see one module called Master Arbitrum Orbit. You can go to that module, and if you scroll down, you will see this chapter called Hands-on Deploy Your Chain. You need to start that chapter. Here, as you can see, I have already deployed one Orbit chain, but if you scroll down, you will see this theoretical content. You can go through it and understand. Then you can go to this deploy your chain section. Here, you will be asked to input your chain name and chain ID. So let's go with my own Orbit chain and chain ID. Here, as you can see, my connected wallet will be the owner of the Orbit chain. So when I click on deploy Orbit chain, you can see the chain is deployed. Here is the address for rollup contract. I can go to this Sepolia RB scan. and I can see that the contract is deployed. Here is the roll-up contract. So this is how you can deploy your own chain. Now, if we try to look at the code base, then you can see that here is the main endpoint, which is deploy chain. So when you click on this deploy chain button, the request goes to this endpoint. Here you can see it verifies the request, and here you can see the deploy chain function, which is in our Orbit service file. Here is the deploy chain function, which validates the deployment request, then create Orbit config. Here you can see the name, chain ID, owner, batch poster, validator, max data size, native token, etc. Chain configurations. Then here we have execute Orbit deployment function, which actually executes the deployment. So here you can see we have imported these functions from Orbit SDK. We are preparing the chain config by passing chain ID, owner, and data availability committee set as false. Then we are creating rollup config using create rollup prepared deployment params config function imported from the SDK. Here we are passing the public client, chain ID, owner, and chain config. Then we are preparing the rollup parameters, and here we are calling create rollup function from the SDK with parameters, rollup params, account, and parent chain public client. And then we are executing this function. So this is how the chain deployment works with Arbitrum Orbit SDK. Now let's look at another method to deploy your Orbit chain. For this method, you need to clone this repo, and then you need to make sure that you have installed Docker and Kurtosis CLI. From these installation instructions, Kurtosis is a tool and orchestration engine. So you can think of it like Docker Compose, but it handles complex deployments. It manages services, like it starts and configures multiple Docker containers. It handles networking so that all the services can communicate with each other. It executes deployment scripts inside these containers, and then it captures deployment outputs like contact addresses for later phases of our deployment. For our deployment, Kurtosis is managing 6 phases. Phase 1, which is L1 setup, and for our case, it's Arbitrum Sepolia. Phase 2, it deploys rollup contracts, which means this step deploys our chain. Then in phase 3, it configures nitro nodes for our sequencers and validators. Then in phase 4, it deploys token bridge contracts. And in phase 5, it funds L2 accounts. And finally, it deploys block explorer so that we can see the transactions. We don't need to manually perform each step, as Kurtosis handles it all automatically. I have already cloned this repo, so let's look at the code base. Here is our main file, arbitrum-sepolia.yaml file. This is where you define your chain name, chain ID, the accounts that will operate it, and importantly, the L1 RPC URL, which is Arbitrum Sepolia in our case. Now let's look at another file, which is deploy with env.sh. It's a script which does 3 things. It loads your environment variables like owner private key, sequencer private key, and validator private key. Here is an example env file. Here you need to configure your owner, sequencer and validator's private key and addresses. Ideally, these all should be different, but for development, we can have it the same. So the scripts loads these environment variables and validates these. Then it loads our configuration file and creates another temporary config file with the environment variables that we have loaded from .env file. And finally, it runs this kurtosis run command. This command runs from the root of the repo with our temporary config file passed as argument. So now let's try to deploy it by running this script. So here, as you can see, it has loaded environment variables, validates the environment variables, and uses the config file. Then it starts the Kurtosis engine and pulls the Docker images needed for the deployment. So if you go to this Kurtosis folder, you will see this rollup creator folder, which contains one Docker file. If we look at it, then it installs the necessary dependencies and it clones this repo. So if we look at this repo, the Nitro contracts repo contains all the contracts needed to deploy your own chain, and it has this one script called deploy creator and create rollup.ts. So behind the scenes, what's happening is the official Nitro contracts repository is cloned. It builds all the contracts with Foundry, runs the hardhat script that we saw, and the script creates rollup creator factory contract, calls create rollup function with our configuration. The factory deploys the actual rollup, bridge, inbox, and other necessary contracts, and then it stores all addresses extracted from the deployment outputs. Now, as you can see, the deployment is successful and we have all the outputs like block scout URL, sequencer URL, validators URL, etc. Now, if we go to this block scout URL, which is a block explorer, you will be able to see all the transactions happening on recently deployed Orbit chain. You can see all the transactions. Let's open up this. You can see all the details. Now, if we scroll up, we will be able to see these output logs from our deployment process. Let's copy these and open it up in a new file. You will be able to see all the deployment logs. You can see the sequencer details, validation node details, validators details, chain info, our chain ID that we had configured in this Arbitrum Sepolia YAML file. If we scroll down, we will be able to see all the rollup contracts like bridge, inbox, owner, rollup address, sequencer, inbox, and outbox. Now, let's try to import this chain in our wallet. So we can click this select network button, add a custom network. You can copy the network name from our config file. The RPC URL will be the validator's RPC URL. Chain ID and currency symbol will be ETH. And as you can see, the network is added and some ETH were breached to my account. Now let's try to run this bridge script. which bridges some ETH from Arbitrum Sepolia to our newly deployed Orbit chain. Before we do that, we need to change the inbox address and RPC URL for our Orbit chain. So you can get the inbox address from the deployment outputs and RPC URL. Now let's try to run this script to bridge 0.0001 ETH to our address, and as you can see the transaction is sent to Arbitrum Sepolia and it will be confirmed within few minutes on our Orbit chain, and we should be able to see 0.0001 ETH in our wallet. If we try to look at the transactions on Arbitrum Sepolia, you will be able to see all the transactions like contract creation and recently sent deposit ETH. So as you can see, we have successfully bridged 0.0001 ETH from Arbitrum Sepolia to our Orbit chain for this address. Let's look at the balance. As you can see, I tried to bridge 0.0001 ETH twice, so my balance is 0.0002, and you can see the transactions as well. So that was all about Orbit chains. Deploy your own chain, access it and maintain it. Thank you for watching this video.